Hello, Farm Tech friends. Okay, so Steph, you sent me some of these alligation problems to work out. Yeah, it looks like there's a whole bunch of math in this problem set. It looks like it's on page 256 of your book, Unit 3, Specialized and Advanced Pharmacy Calculations. I think the ones you all wanted me to work were the alligation ones. You kind of wanted to see them a couple different ways, so I'll do a couple of those. So that looks like, yeah, actually, yeah, it looks like this 7.2 part here. So I'll just look down here and grab one of these. One of the ones that was, I'm just looking here. Yeah, they're all kind of the same kind of problem, right? Yeah, we'll do a couple. You wanted to see them worked both with the tic-tac-toe board method and also the algebra way. So we'll just do a couple of those, and then we'll call it good. So we'll just grab one here. We'll do this. I'm looking at this one right here. You need to prepare 500. This is number 5. Number 5 in the book. You need to prepare 5. Oh, wait a minute. Maybe we should do the evens. I wonder if you have the same thing that math textbooks have sometimes, which is the odd numbers are answered in the back. So we'll do an even one. You got to make 500 milliliters. This is number 8. 500 milliliters of, it looks like 12. I'm guessing D 12.5 W means 12.5 is the percentage of the solution. I don't know what the D and the W mean. You've got 10 and you've got 20, so you've got a little bit of each. How many milliliters of each do you need? Okay, so we know we need, put this over here, we need 500 mil of 12.5%. All right, so we'll do it first tic-tac-toe method, and then we'll go back and do it with the equations for the couple of you that like that. We have 10 and 20. All right, so you've got tic-tac-toe board. I still like this. This is super fun way of doing it. So you got 10 and you got 20. You need 12.5. And then you just subtract diagonally and ignore the sign. So this is going to be 2.5 here, and that's going to be 7.5 there. Okay, so the ratio you now need, now I know what y'all, when we were in class together, I'm not sure, I want to make sure I say this correctly. When we were in class together, when I look at those numbers, I recognize that that one's 3 times as big as that one. So my ratio would be 3 to 1. Which means you need 4 total parts of the 2 ingredients. So when you add them together, 3 of the 4 parts are going to be the 10%, and 1 of the 4 parts is going to be the 20%. So we're going to start with the 3/4. We're going to multiply that by the 500 milliliters, and this is going to tell us how much 10% we need. Okay, I think I can actually do this in my head. 250 would be half, 125. That's going to be 375 milliliters of 10%. And then the other 125 is going to be the 20%. In case we spoke earlier of not just assuming that, but instead calculating it. Because you can subtract that from 500 to get the remaining 125. But if you did this one wrong, then next one will be wrong too. So let's just do the 20% the same way. We're going to have to take 1/4 of the 500 milliliters that we need. And that's going to be, yeah, so half of 500 is 250, half of that is 125. So that's 125 milliliters of 20%. And you can double check yourself by adding these two together and make sure they add to that 500. So I think we're good. I love this. This method is so intuitive. It's kind of fun. Also, it gives you a nice self-check at the end there. It gives you a nice self-check. You can go back and look at what you need. It also ties into the intuition that a lot of you said that you're going to need more of the lesser drug, which makes perfect sense because 12.5% is closer to 10 than it is to 20. So that should sit well with you. Okay, give me a sec here. Let me clear the board, and then we'll do this the algebraic way, which some of you like to see. Okay, so with the algebra, there's a couple ways you can do it. When I ran the algebra with you all in class last week, it looked like you like with two variables, x and y. So we'll just stick with that convention. We'll let x equal the milliliters of 10% that we need. And we'll let y equal the milliliters of 20% that we need. Now there's two equations you're gonna need. You need two equations. If you have two variables, you need two equations. So the first one, the obvious one, is we know that however many milliliters of 10% added to however many milliliters of 20% has to be 500. Like we know that for a fact. X plus y equals 500. This is the volume equation, right? This is milliliters plus milliliters equals milliliters. That's equation number one. Equation number two is where the work gets done. This is the percent part of the equation. This is actually what the tic-tac-toe board is doing in the calculation, is this percent part. So we know that we're going to take a certain number of milliliters, and those milliliters are multiplied by a 10% solution. And then we're going to add it to another amount of milliliters, which are the 20% solution. And altogether, that is going to be equal to 500 milliliters of a 12.5% solution. Sorry, I was crossing I was mixing and matching there. I got to be careful with my, if these are in decimal form, that has to be in decimal form. Okay, so now you got your two equations. So over on this side, this is the volume equation, and that one there is the, this is the percentage equation. So this is setting up the percentages, that's setting up the volumes. So you need both pieces. The tic-tac-toe board takes care of the percentage. The amount is what happens at the end of this calculation. All right, so the first thing we got to do is got to figure out what an eighth of 500 is. Okay, so a half of 500 is 250. A half of that is 125. A half of that is going to be 62.5. So we know that x times 10% plus y times 20% is going to be 62.5 milliliters. So 500 total milliliters of solution is going to be equivalent to 62.5 milliliters of whatever this drug you're talking about is. Okay, so now this is where the algebra comes in, right? Now we've got this equation and that equation. So I'm going to stack them on top of each other. X plus y equals 500. Now, this is where you need to combine the equations to get rid of a variable. I'm going to recommend, since these are kind of nice numbers actually, I'm going to recommend multiplying this whole equation here by 10%. Because if we do that, that'll make this guy match that guy. Because this will now become 10%. This will also become 10%, and that's going to become 10% of 500, which is just 50. That makes the math kind of nice. Then we can just subtract the equations. This whole equation minus that whole equation. Now, if you do 0.1 times x minus 0.1 times x, that's going to cancel. Done. Here, you're going to get 0.1 times y, because you got 0.2 minus 0.1 equals 0.1. That's good. Then you got 62.5 minus 50, which is going to be 12.5. And these numbers are working out really nicely, actually. This is kind of sweet. Glad I picked this one. You have to either divide both sides of this by 0.1 or multiply by 10. Metric system, and again, we're American, so it's kind of hard to deal with the metric system sometimes. But if you multiply both sides of this equation by 10, you're going to get y equals 125, which you just found out that it takes 125 milliliters of 20%, which if you remember back to the tic-tac-toe method, that's exactly what we got. And then, if you know that y is 125, you know that x is the remaining 375. So this math is being done in the tic-tac-toe board. It totally is. It's just being done in a non-algebraic way. The variables are being swept into the tic-tac-toe calculation, and they're not showing up as variables. So, but they're there. they're there. So your choice, we'll do one more here, of course, just kind of illustrating both methods, but that's how you're going to get, in this one, in number 8, this one's number 8, right? This is how you're going to get your 12.5% concentration with 500 milliliters of them. Okay, my friends, I'm looking for another one here. You know what I was looking for? I was looking for one, like the very last one we did last Sunday. I don't know if you remember. Y'all asked, maybe this is one. So, okay, I'm looking at page, I don't know what page this is. It looks like it's page 369, maybe. I'm seeing, like, number 8 here. Prepare 1,000 milliliters of D10W, which I'm assuming means 10% solution, using D50W and SWFI. And I have a feeling, I think I know what that is. I'm going to Google it real quick, though. SWFI medical. Swiftly banish. Many clinicians use the acronym SWFI for sterile water for injection. Okay, I think I know what that means. So let's do this one. I think this is going to be good. And it's going to be like the one we did at the end of the day on Sunday together. So we need 1,000 milliliters of 10%. We have 50%. Which means we've got to dilute it down to 10%. Now, up till this point, we liked the ones where we have 10%, excuse me, we need 10%, and we have things like 50% and 2%, because 10's between 50 and 2. Or we have 50% and 3%, because 10's between 50 and 3. Or we have 50% and 1%, because 10's between 50 and 1. Well, you also have SWFI, which is 0%. That's just the water, in this case, I guess, with no drug in it. So we could totally do this the exact same way with tic-tac-toe, or with the equations. We'll do them both. So, tic-tac-toe board. We're needing 10%. 50% is what we have, but we also have 0%. 10% is closer to 0 than 50, so I'm calling it now. We're going to need more 0 than 50. 50 minus 10 is going to give us 40. 0 minus 10 is going to give us 10. God, as a math guy, that's hard for my brain to say that out loud. 0 minus 10 is 10. It's negative 10, but you're looking at the absolute value. These numbers are nice. They're in a 1 to 4 ratio, right? 10 to 40. I know in class we were talking about calling this 10 and 40 summing to 50. My brain is always going to try to find the simplest possible fraction, which is going to be 1 to 4. Summing to 5. That's just, my brain is going to want to do it that way. So for the 50%, we need 1/5 of the 1,000 milliliters, which is going to be 200 milliliters of the 50% drug. And if you feel confident in that answer, that means the other 800 has to be the 0%, the sterile water. But in case you're not confident, just do the math. It's going to be 4/5 times that 1,000 milliliters, which is 4,000 over 5, which is 800 milliliters of the 0%, or the sterile water for injection. So there you go. There you go. So I like this one. This was, I remember the confusion was how the book solved that problem. But here's the thing, as I'm looking through your problems, I mean, there's 3 pages of Alligations that are all solved the exact same way. I mean, if you like the tic-tac-toe board, do the tic-tac-toe board. If you don't, let's do it with algebra. So let's do the finger snap trick again. That never gets old to me. Okay, so equation method. We're going to have 2 concentrations of drugs we're combining. I guess technically 1. One's going to be the milliliters of the 50%, and 1 is going to be the milliliters of the 0%. Okay. Now I'm thinking a little bit ahead to where we're going to be. I'm going to write the easy equation, which is x plus y equals 1,000, because that's the total volume we're combining. X plus y equals 1,000. So that's 1,000 milliliters of drug and diluent. And then there's the percentage one that we have to combine, which is, and this is where actually it gets kind of nice, x times 0.5 plus, this is where it gets really fun, y times 0 equals 10% of 1,000, which is 100. So that's how many total milliliters of drug are in this. 1,000 total milliliters of solution, only 100 of it is drug. Now what's kind of cool about this is we don't even need this second equation right away, because look what happens to the first one. The first one, y times 0 is just 0. So this whole thing just reduces to 0.5x equals 100. So a half of x equals 100. That means x is 200, which is exactly how much of the 50% we said we needed. We needed 200 milliliters of the 50%, which means the remaining 800 milliliters are of the I forget the acronym, but the sterile water for injection, SWFI. I think that's what it was. No, let's do one more. Let's do one more where we don't have a 0%, because the interesting ones are the ones where you don't have a 0%, because you do have to solve the system. So let's go back in here. Okay, standard water for injection is all that. Let's go back to the original chunk of them. What's this? 14. 45 grams of zinc oxide. This is number 14 in your book here. I think it's still page 369. 45 grams of zinc oxide, 10%. All right, so we have two, one above 20%, one below 5%. Okay, so first off, of course, our good buddy tic-tac-toe. We got 20, we got 5, we need 10. 20 minus 10 is 10, 5 minus 10 is 5, so we know the chunks are going to be in a 1 to 2. Again, you can call that 5 to 10, adding to 15. My brain thinks of it as 1 to 2, adding to 3. Fractionally, it's going to be exactly the same thing. Fractionally or percentagely. I just said percentagely. I'm pretty sure that's not a word. But fractionally, if you go 5, 10, 15, it's going to be the same as 1, 2, 3. Okay, so for the grammage that we need, grammage is also not a word, I don't think. Apologies. 1/3 of that 45 grams, which is otherwise 15 grams, that is the 20%. You need 15 grams of 20%. The other 2/3 of that 45 grams is going to be the 30 grams, and that's the lesser 5%. So again, this sits well with your logic of which one goes with which as far as the numbers go. So you need 15 grams of 20% and 30 grams of 5%. Combine those two together, and you end up with the 45 total grams you need. Let's do it algebraically as well. I won't do the stupid snap trick this time, because I think you're getting tired of it. Although I shouldn't have erased the 45 grams of 10%. 45 grams, 10%. Okay. Now, we know we have 20 and 5, which are the two variables. X is how many grams of 20%, and Y is how many grams of 5%. So once again, just the easy equation is X plus Y is 45 grams. That's the total amount of the solution, ointment. Is that what it was called? Yeah, an ointment. So you're going to have 45 grams of ointment. So X plus Y equals 45 grams. How much of that ointment is going to be the drug? Well, if 10% of the ointment is drug, that means it's going to be 4.5 grams of drug. Some of those grams come from a 20% solution, so that's X times 0.2. And some of those come from the 5% solution, that's Y times 0.05. Don't forget that O for 5%. It's an easy thing to forget to do. Okay. I vote, what's the easiest one to get rid of? I bet you it's probably easier for the 0.2 0.2, let me just think, I'm trying to think math. It doesn't matter which one we multiply by, either 0.2 or 0.05. That one I can do in my head easier, so let's do that one. So I'm going to multiply this whole equation by 0.2, which is going to put a 0.2 next to the x, which is what we want. We want to cancel those. 0.2 next to the y, which is okay that we don't cancel these. It's totally fine. And then over here, 0.2 is the same as taking 1/5 of this. So 1/5 would be 20%, which would be 9. There we go. We just cut 45 into 5 equal pieces. That's going to be 9. Now, bear with me here because I'm feeling saucy. We could subtract straight down. We could. That minus that cancels. The only slight kick is if you do that minus that, that's going to be a negative number, and then that minus that is going to be a negative number. Now, if you can live with that, that's totally fine, because then it's negative on both sides, which means the y has to be positive. But I'm feeling saucy. So I'm going to subtract this minus this. So 0.2y minus 0.05y is going to be 0.15y. Positive because I subtracted that way. And then this one, 9 minus 0.5 is going to be 0.5, or 4.5, excuse me, 4.5. Hopefully that was okay. I hope that was okay. That didn't piss you off too bad, did it? Okay. Let's say you didn't, let's say you subtracted down, then they're both going to be negative. And when you do the next step, which is dividing by that 0.15, you'll divide by a negative, which will cancel the negative. So it really doesn't matter which way you do it. If you divide by 0.15, my brain thinks, if that was 1.5, that would be 3, but it's 0.15, so that means it'd be 30, which means we have to put 30 grams of 5%, which is exactly what we figured out before. Which means the other 15 grams, because together x plus y is 45, and that was the original equation that I've since messed with, is going to be the 15 grams of the stronger solution. So there you go, friends. Yeah, it's funny. Thank you, Steph, again for teaching me the new word alligations. I never knew what that was until you reached out to me, and it's kind of fun having that background now as to where this kind of math is actually important. And the tic-tac-toe thing, that was fun to learn too. Those of you that like it, use tic-tac-toe. Those of you that don't, use the algebra. Or if you're feeling saucy, do it both ways. Don't do it both ways. Pick your favorite. We'll see you soon.